My name is Alex Jennings, and this is how you build a new spear for your spear gun. Let's get started. I started fishing with my brother when we were young, and then as I got older, I enjoyed being on the water with friends. Spearfishing combines my two passions and is a perfect application for the Design for Manufacturing project. Standard spears handle the small fish very well. The fish stay on the spear shaft, and the fish don't break the spear when they're trying to shake off. Well, maybe not that small. For bigger fish, however, normal spears can be shaken violently and even broken, or the fish will use the spear as a lever and shake itself free. Therefore, I am designing and manufacturing a spear shaft with a slip tip. This way, the fish can shake violently but does not damage or shake itself free from the spear shaft. The spear tip embeds itself in the fish and disengages, acting like a barb. However, the fish still remains attached to the spear and spear gun. The slip tip will be made from PEEK plastic. PEEK plastic is impact resistant, UV stable, chemical resistant, and has a high yield strength. Most importantly, it's great for marine applications because it absorbs almost no water. For high volume production, the slip tip should be plastic injection molded. Plastic injection molding yields high volumes with low unit costs. This spear tip design can be replaced easily in the field and can be maintained in the field because it is plastic and sharpenable with a dive knife. The spear shaft is made from high silicon bronze, which has a relatively high density for better penetration in larger fish, a high yield strength, and excellent corrosion resistance. It is also easy to machine and weld. For high volume production, the spear shaft will be CNC milled. CNC milling can be fully automated for high volume production, low tooling costs, low setup costs, and relatively low unit costs. Like most projects, we begin by measuring the stock materials for cutting. In this case, a 1/4 inch round rod of bronze, as well as a 3/8 inch round rod of PEEK plastic. Using a hacksaw and a guide, we straight cut the round rod pieces into the desired lengths for our project. Using a miter saw, we quickly cut the PEEK plastic rod to length. Always make sure to wear safety glasses and gloves when you're using power tools. The new spear shaft shares similar dimensions with the existing spear shaft, so we use the existing spear shaft as a guide to mark the holes that we need to drill for the attachment sides of the elastic band wishbone. We also mark the flat tail grind and the locking mechanism notch. These features allow the spear shaft to be securely locked to the spear gun. 2 table vices with horizontal V grooves are used to securely hold the spear shaft while we grind. A standard Dremel with a tungsten carbide cutting bit is used to cut and grind the spear shaft. A trick I learned is to install a small spirit level on the Dremel to keep your grinds reasonably level. A pair of digital calipers are used to quickly check the tolerance. Next, the spear shaft is flipped over to create the locking mechanism notch, checking the tolerance again for a secure fit. Not too shabby for a Dremel. Some of you may be wondering, why not use a mill for this? Well, I wanted to show that the average consumer could use basic tools to create this spear. This step is very important. Here, we check that the spear shaft securely locks in the spear gun. I know I'm not shooting anything that doesn't lock securely in a safe. The locking mechanism features of the spear shaft are fishing ready. Now we measure and mark our holes for drilling the slip tip and spear shaft. Starting holes with a center punch reduces drill bit wander. The spear gun launches a spear by using elastic bands to throw the spear down the spear gun barrel. These two holes will be the attachment sites for the spear gun bands. A through hole is drilled near the end of the spear shaft. This is where the slip tip attaches to the spear shaft with the spear gun line. This through hole is countersunk to seat the stopper knot. Spear shaft fins for the elastic bands to attach to are created from inexpensive wood chip nails. Using bolt cutters, the wood chip nails are quickly cut to size. These small pegs fit nicely in the spear shaft holes and create inexpensive fins. Now we move to a well-ventilated area away from any flammable objects to braze the spear shaft fins in place. The general brazing area is lightly heated before concentrating the flame on the specific joint. The high heat MAC gas torch and heated joint are easier to see in the low light condition. As in soldering, the base metal is heated until it readily melts the filler metal. This is known as wetting. Capillary action drives the filler metal flow. Phosphorus copper filler metal is used for this project because it has a low melting temperature and doesn't require flux. The fin on the left is my second try. It's better quality. Now it's time to finish up the slip tip. First, the cavity is drilled where the spear shaft will enter. I'm making sure to slowly increment the drill bit sizes for quality drilling. I've decided to create a small flat surface here instead of using the center punch. Now the final hole is drilled, which is a through hole in the slip tip shaft. Using the Dremel again, a sharp tip is cut on the front end of the slip tip. The last step is the assembly, and the assembly is very easy. It involves one component, a piece of spearfishing line. Essentially, two stopper knots are tied on each end of the spearfishing line after it is thread through the spear shaft and the spear slip tip. These knots are pulled tight see, the knots seat themselves in the countersunk holes of both shafts. The slip tip simply slides on to the front of the shaft. Now for the fun part, testing out the completed prototype at Newport's South Jetty. Unfortunately, the slip tip did not deploy and this fish got away. Unfortunately, this surf perch got off the spear as well. Finally, success. Soon after the prototype's success, it utterly failed. The brazed welds simply couldn't withstand the force from the elastic bands. I went back and swapped out the prototype with a fresh spear and kept on fishing. It was a good day overall, and I got several black rockfish. But my friend Sebastian really took home the glory with a nice, fresh lingcod. Oh yeah, Andy found his GoPro.
Oh, come here!
To help the slip tip disengage properly, I embedded a piece of the bronze rod inside the slip tip cavity. This prevents the spear shaft from embedding in the softer plastic material when it strikes a fish. Round 2 of testing. Alright. In addition, the braze joint strength may have been increased by decreasing the joint hole clearance and heating the base metal to a greater temperature before applying the filler metal. A special thanks to the think tank for helping me with this project. Thank you Dr. DuPont and Chris for a wonderful class and term. Thank you Eileen and Sebastian for helping me film and make this awesome video. And finally, thank you Aaron Halbert and Duffrey for the sick beats. Thanks for watching, everyone.